All right, so yeah, Razor. Before I talk about Razor, I'm going to talk about what Razor is a little bit to give everybody kind of an overview of what it does. I'm going to talk about what we've been doing with Razor, especially over the last couple of months, and then at the end where I see Razor go and I think what roughly a roadmap is, and I'll do the very scary thing at the very end and try to do a live demo of what we have. And keep fingers crossed. I hate live demos. OK, so who am I? I've been with Puppet Labs for about 3 months now. I've known Luke and Puppet for a lot longer than that. I think I first met him in like early 2006 when we went out for dinner in the Richmond here in San Francisco. And back then you could fit the Puppet community around one table in a restaurant. It's absolutely amazing to see how the community has grown and how many of you are involved and interested and show up to these things. It's fantastic. Part of my involvement with Puppet was that I started Augeas because I was frustrated with past file providers. And then for the last couple of years, I wasn't really involved with config management much anymore. I worked on Apache Deltacloud, which is an infrastructure as a service abstraction API. And I also had the honor to sit in a working group of a standards body, the DMTF's CME group, which produced a standard for a cloud interface. But when I started at Puppet, the first thing I was asked to do was to look at Razor and kind of help move it forward. So just a little history about Razor. Razor is still really, really young. It's a little over a year ago. It was launched at EMC World last year, and then at PuppetConf, I think we announced that we would take over the code. It was started by Nick Weaver, who just gave the keynote this morning, and Tom McSweeney from EMC, now VMware, and then Nan is here. He was also one of the early collaborators on it. And it's been fascinating to see how much interest there is in it. I mean, this room shows it. I did a meetup a couple of weeks ago and was totally blown away by how many people are interested in it. And I hope we'll get to a point where everybody's happily using it. And I mean, for me, this is kind of not just a way to dump a bunch of information on you. I would really like this as kind of start of a dialogue about features, future, whatever, because the community is what counts around open source tools and Razor in particular. So the thing that, in my mind, makes Razor unique is that if you look at all the other provisioning tools, they force you to look at your bare metal or VMs as kind of as pets. You have to get to know them really well. You have to write down the MAC addresses of these things and know which MAC address goes with what system. Then you go and enter the MAC address into the system, into your provisioning system, and say this gets CentOS 6, based on some knowledge that is in a spreadsheet or somewhere. And what Razor does really is it lets you treat the machines you're provisioning as cattle, like as things you kind of categorize, right? There's young cattle, milk cows, cows you raise for meat, but you don't care about each individual one. And the same way, Razor lets you treat your machines as, this is an old, small machine. This is a, big machine that can run our database server. Basically lets you classify machines. And the way it does it, there's kind of 3 key ingredients for that. Actually, the clock up here isn't running. It would be really helpful. Or somebody can tell me when the time's up. So there's 3 ingredients. One absolute key ingredient, I mean, I've played with provisioning tools in the past, and you invariably wind up in that TFTP misery because a TFTP server doesn't let you do very many things. So one of the key ingredients is iPXE because it lets you go from TFTP to HTTP, and the Razor server is basically just a standard web server that does things. When machines boot, they get some iPXE file that tells them go get what you actually should boot from this web server over here, which is the Razor server. And iPXE is the piece that makes it possible. The other ingredient is the idea of actually first discovering and inventorying your hardware so that you can later classify these things and decide what should go on the machines. So yeah, as I said, I've been with Puppet Labs since May, and have been looking at it, and we've taken over stewardship of the code about a year ago, and we really want to turn Puppet into a product. Do kind of the same thing we're doing with Puppet, with Razor. Have an open source community version, all that, but also a commercially supported version for people who need that. And with an eye to that, we decided that the best way forward would be to rewrite Razor, to kind of keep the key ideas that make it unique and really valuable, but change the stack it's based on and change some of the implementation details to make it easier to deploy. That was one of the big takeaways. What we learned over the last year is that people really struggle to deploy Razor in its current form, and also struggle with keeping it running just because it's got components that people aren't that familiar with. From our kind of productization view, we want to simplify the maintenance of the code base, of course, for that, and also make it a little easier to use in some areas. As I said, we don't want to muck with the good bits. We don't want to destroy functionality that's there and makes it unique and valuable. And this is kind of my take on what makes Razor unique and valuable. If I'm missing things, come up afterwards. Let me know what you think. In your mind, makes Razor unique. The things that make it really, really useful is this idea of booting into something called the microkernel, a small OS image that runs factor and then sends facts back to the server. That's how Razor decides how to classify machines. That you use iPXE to boot. That is written in Ruby. The tag policy system, I'll talk about that in a minute. Then another key, a really big key ingredient for Razor and what attracted us is that it helps us close the loop from going from a machine with nothing on it to a machine that's managed by Puppet. And kind of the synergy with Razor and Puppet really is that Razor took the view we want to do the minimal amount necessary to get a machine up and running and enrolled into a Puppet master. And so it has nice hooks for doing that, for enrolling your machines, your nodes into a Puppet master. The stack we're rewriting it on is pretty much a standard web app stack. We're using, as the database, we're using Postgres, relational database. Simply, there's many reasons for that. One of them is it's a very known quantity. People know how to deploy Postgres, how to back it up, how to cluster it, all those things. And I'm personally really impressed with how Postgres has stood up to kind of the NoSQL challenge. A few years ago, everybody was like, relational databases are a thing of the past. And a lot of people confused some of the NoSQL tenets with that NoSQL means schemaless, which is NoSQL means way more than schemaless. And Postgres has done a beautiful job of integrating kind of the schemaless things into a relational database. So it's a great data platform. We're using Sinatra as the web framework, which, if you're not familiar with Sinatra, you can think of it as Rails after a very, very serious diet, or maybe Tomcat for Ruby. I don't know, something like that. And then to deploy Razor, because we need to do a lot of things that get kind of awkward in the traditional Ruby web app kind of deployment thing, where you have to where your application consists of like 5 different processes, because there's a web server and something that pulls the database to pull tasks out, and something that reads stuff from IMAP, although Razor will probably not read email anytime soon. So TalkBox is a plugin for JBoss that basically turns JBoss, a Java application server, into a Ruby application server. And as a developer, you get all these things. As a sysadmin, it means developers can do all these things, and you only need to monitor one process. You don't have to worry about keeping 10 things running. So I mean, if more people use TalkBox, there would be a lot of Ruby code that could just go away. Okay, so the components of Razor are what's on that slide here. Of course, you have a server, which is the Postgres database, and a web server. We also have a command line interface to control the setup, to control what gets provisioned on what machines, and import images and those things. We've kind of separated this discovery image, the microkernel. There's two aspects to it, really. There's just a fairly generic small OS image, and then on top of that, a little agent that runs. And the agent, really, all it does is run factor, send the facts back to the server, and then sit there and wait for the server to tell it what to do next. And what to do next is generally hang tight or reboot the machine. And to make it easier for people to try to play with other OS images underneath that, we kind of pulled those two components of the microkernel apart. And then there's, at Rackspace, there's people who are working on a UI. I'm not sure how, because it's an intern doing it, I'm not sure how far they'll get, but I think that would be a fantastic addition to Razor, a little UI that helps you figure out what's going on in your Razor installation, help set things up. Okay, so the microkernel for Razor used to be based on something called TinyCrawl Linux. And I mean, they're not kidding when they say it's tiny. It's, you get a 60 meg image out of it. The downside is that there's no commercial support for TinyCrawl Linux. So if it doesn't boot on your machine because you have some NIC that it doesn't like, you're kind of on your own. And again, for us to have a supported offering, we can't be in the hardware support business. But there's people who are in the hardware support business that give you, Linux distributions with well-known hardware support. And so we're moving the microkernel to an enterprise Linux base, which probably means in the open source version, we'll use something like CentOS. Right now, the microkernel I have is built on Fedora, but going to CentOS is not going to be a big deal. And then, for people who have RHEL or SLES or whatever subscriptions, we make it easy to build their own image that they can use. The downside is that the image is a little bigger than what TinyCrawl Linux gives you. I don't think it's a huge deal on your provisioning network, because the next thing that happens on it is that you install an OS, which will cause way more traffic than the microkernel. Okay, the server API is, it's all different from, we completely changed it, but kind of the philosophy behind it stays the same. It's a mostly RESTful JSON API. We're going slightly, one of the things that is always really, really awkward in REST is when you want to make changes to a REST interface, you get into these weird situations where it's very unclear how to express things. And architecturally, because it gives us a little more latitude internally, we're going to like a command pattern where all the changes you make, there's commands that, but a command really just means there's a URL for it, and you send some JSON document that says, here's an image that I want you to import or something like that. And then a really important component that we absolutely need to get going before too long is authentication. We need to. The Razor server really has two APIs. One is the API that a node uses to talk to the server, to get things from the server. And the other one is kind of the management API that an administrator uses to control how things get booted and what operating systems wind up on which machines. And that part is the one that really needs to be secured and authenticated and all that. The node server thing is, because of what it does, is pretty much impossible to secure. You just have to use networking rules to keep people off the network. Okay, so here's a few examples of what the command line looks like for Razor. The first command lists all the nodes that the system knows about. The second one gives for the tags collection. There's a specific tag, my tag. It prints out details of a tag. The rest of that slide are commands that one of them creates a tag. And as you can see, we also changed the syntax for how you express tags. It's the language to do that is much more powerful now than it used to be. And I'll give a few more examples about that in a minute. Create an image. Supposedly you have an ISO somewhere, and you import it on the server. And then create a policy. So in the command line, you can either specify all the kind of the attributes that the command needs, like a name, rule, image URL, or you can stick it all into a JSON file, because some of these take a lot of options, like creating a policy would be a very long command line. You just stick into a JSON document and just post that to the server. So tags. Tags really are nothing more than a rule with a name. And later on, you use those names when you set up policies to tell Razor what to boot. A rule can be pretty complicated Boolean expression. There's an in operator. So what this does, and I think I need the hotfix slide from the T-shirt because this is missing a square bracket here. But what this does is, so when these rules get evaluated, they get evaluated against the node. A node boots into the microkernel, gathers the facts, sends them to the server, and the next thing the server does is it evaluates all the tags and sees which of the existing tags match that node. And during tag evaluation or rule evaluation, you have access to the node's fact. So this rule here says, take the MAC address fact, and if it's one of those that I have listed here, the rule matches, or if this box has 2 processors, then whatever that tag is, it matches to. And this matching by MAC address kind of gives you a backdoor for very simple cases where you really know I only want this on those machines. Okay, so policies are the point in Razor where everything comes together. They connect up images with installers, brokers, tags. And what these things are, so an image is just an ISO, a repository of bits that you want to wind up on a system. The installer is the metadata about how to actually get these bits on there, and it contains things like a kickstart or pre-seed file and maybe a script that you want to run post-install on your machines. And it's fairly arbitrary what you can do in there. A broker is the Razor expression for the thing that enrolls you with a config management system. And a broker, broker consists of what config management system it knows how to, there's like a Puppet broker, but you need to tell it what the server is. So you have to set that up separately. So the Puppet broker here, the thing that's called Puppet, already knows where the Puppet master is. We set that up outside of the policy. At the very bottom, it talks about what tags need to be on a node for this policy to match. So this policy will match every node that's tagged with a tag called any. Line number, the thing second from the bottom. All the policies that Razor knows about are processed in order. So once Razor has applied tags to a node, it goes through all the policies it has in ascending order by line number and sees which of them matches with the tags, and that one, the first one that matches gets applied. And if none matches, the node just sits there and continues checking in with the server every so often, every 15 seconds or so. So that once a new policy is added and it matches, you immediately get machines installing that policy. You can limit how many nodes should be installed with a given policy with this max count. This says that this policy can only be used for up to 20 nodes, and once you have 20 nodes running this policy doesn't apply anymore. And maybe there's another policy later on in the policy table that matches the same things but does something slightly different. So installers. Installers are the thing that, as a user, you'll probably have the most fun with to get Razor going, because that's really the part where you write down how you want to have your machines installed. And it used to be that for that you have to write some Ruby code, but in the rewrite, an installer is just metadata. It's a YAML file and then a bunch of ERB templates. And the simple installer might consist just of of a kickstart, little templatized with ERB, or a kickstart file that then downloads a post-install script, puts it on the machine, reboots the machine, and runs that post-install script. There's a very simple API for the node to get things from the server, so that during your kickstart, for example, you can say, give me my post-install script, evaluate the post-install script template, and give me the result of that so I can store it somewhere. It also lets the node log things like, I'm almost done with my kickstart file kind of things. And you can store some values on the server. Right now, we only allow you to store the IP address. So during installation, the node can report back what its IP address is, but we'll make it a little more generic in the future. Okay, so this is the metadata for an installer. That's all the metadata you need to write to get an installer going. And the first 3 lines are just to make things a little pretty. The really only operational part is this boot sequence here. So all the installers I've seen, I know about, is they all work in the same way, which is first boot into some installer, then maybe boot into something else. If you're installing Windows, you might have to boot into an installer 2 or 3 times. Eventually at the end, at some point you're done, and then you just want to keep booting the system locally. So what this says here, the boot sequence, is really just the first time we're using this installer with the system, use the boot install.erb template, evaluate that, send that to the node, and after that, boot locally. And these things need to be iPXE scripts, what they produce, boot install and boot local. So they're iPXE scripts that say, use this kernel and this init.rd. And here's like 2 snippets, because I couldn't fit a whole thing on the screen. But at the top, you have a little snippet from the boot install IRB iPXE file. And it says, the kernel we want to use, image URL, produce the URL to the image you're using with the current policy. And then within that, the VM Linux file, and the kickstart file URL produces a URL that evaluates the kickstart.erb for this installer. So when you boot this, it'll get the kernel, and eventually the kernel boots and looks at its command line and sees there's a kickstart file and loads that. Similarly, this is a snippet from like the post-install script that at some point calls the host. So this is a shell script eventually. It calls the host name command. You have access in these templates to the node object, so you have access to the facts and some other metadata that we store. And down here we run a yum command, and then if that fails or if that succeeds, we just tell the server everything's okay, and if it fails, we log an error on the server. This is a little subtle because when the template gets evaluated, all you do is you generate a URL back to the server, and only when the script is run does this curl line get executed. But all the details about what the current node is and what the installer is gets encoded into the URL by these helpers. Okay, so that's kind of what Razor looks like after the rewrite. I was hoping we would get a release out by PuppetConf, but I think PuppetConf, we would have had to push PuppetConf by a week or 2. And that apparently wasn't possible. So we'll have a release up very soon. There's on the GitHub repo, the GitHub repo is razor-server in the Puppet Labs account. There's installation instructions and just how to install it from source, which isn't very hard. The main difference between a packaged and non-packaged version is that there's a git clone command somewhere instead of a gem install. And so the thing that I'm really excited about with Razor is beyond the kind of very, very flexible installation provisioning that it gives you, is that because we have a server that knows a ton of stuff about these nodes and has ways to make these nodes do things, that it would be really easy to turn Razor from just a provisioning tool into a kind of provisioning and lifecycle management tool. so that during the whole life cycle of a piece of hardware, Razor can do things with it and know things about it. And kind of the three big features that would get us much closer to that are, for one, the ability to store user data in a node, which is not very hard, so that you can come in through the API and say this node should always be turned off, or this node set some attributes that are outside of facts. I know that this node is at the top of its rack or something like that through the API. The second one, to give you the ability to execute commands. Like commands could be update the BIOS, right? So that you can say on all nodes that match this kind of a tag rule, run a BIOS updater, because the tag rule catches all the nodes you have that need that new BIOS. And then finally, Razor already has kind of a life cycle for machines, for nodes, to expose that life cycle by generating events at key moments, so that when a node shows up for the very first time and Razor is going to boot it into a microkernel, you can call out to some other system and say, hey, this thing just showed up. I've had somebody ask in another talk, I have another CMDB somewhere, and can you give me information to stuff into there? That would be the way to do that. So I mean, here's some ideas for what commands I think would be really useful to do against nodes. Like I said, BIOS firmware update. There's also, if you've used Razor for a while, you might have built a new microkernel with that gathers new facts that you don't have about your old nodes. So you might want to just do one more round of rediscovering the node, but not changing anything that's on the node. And I'm sure and that would be something I'm very curious to hear, what your ideas, what your needs are in terms of what things you want to do with nodes, because that list will certainly grow over time. And then, events, as I said, here's just some ideas of where we should emit events, and we'll give you a way to control what happens on an event, either some sort of webhook thing where you can call out to another server, or trigger some of the commands that I had on the previous slides. Those kind of things. All right. Now to the scary part.
I'm not scared.
Huh? Good. At least one person in this room isn't. All right, where's my terminal? What just happened to my terminal? Oh. Yeah. Thanks. Okay. So for the demo, I'll start with a clean database. All you need to do is run this rake task. This basically drops the database and loads the schema at the same time. And then I start the server. Okay. So this was just the talkbox log. Talkbox starting up. And because at some point we'll need an image and it takes a little while, first thing we'll do is we'll load an image into the server with this command. I mean, similar to what I had on the slides before. Image URL can either be a file you have locally on your system or on the server, or it could be an HTTP URL, and the Razor server would then actually download the image. Okay. As you can tell, I've actually practiced this demo, and it's all in the shell history. Okay, and so for all commands are all asynchronous. So yeah, the thing comes back, and the image is, of course, not imported yet. It's just working on it. But yeah, for all commands, it returns you, amongst other things, the ID, the URL to what you just created here, so that you can then later go and check out how far things have progressed. The other thing we'll need is this broker business. I'll just create that now too, because I always forget to do this. Okay. And because we won't have time to run through the full install, I'll just use a no-op broker, which does nothing at the end of the install. So once the installer has finished, Razor immediately figures out what the broker should be and runs that. Okay, and so now we can look at our nodes. And we have none, as we should, because we haven't booted anything. So let me boot a node. Yeah, this is a virtual machine. It's a completely blank virtual machine. I've given it a blank hard disk and set it to PXE boot from the network. And the installation instructions on the GitHub wiki talk about, there's a couple things you need to do to your TFTP server to get that all going, but it talks about how to do that. And let me see if I can stop things at the right point. Yeah, let's see. So what happened so far is so it booted from the TFTP server. It got an iPXE file, bootstrap.ipxe, which is something I put there, which just tells the node to go and go to this URL here on the Razor server. And then it went to download the microkernel and enroll the system into Razor. And so with any luck, we should now have a node in our node list. We do. We can look at the log. Sorry. So each node stores a little log with it, which is a JSON array of things that where we log. Here, for example, the node has booted, and when. We can also look at, this is a lot of fun on a small window, the information about the node, which is a lot. So we have like the generic metadata about it. It's the URL for it, a name. All objects in Razor now have names, except for nodes. They're all user-defined because you know what you mean with a foo policy or the bar installer. And then it has, down here, these are all the facts that came in from the microkernel.
It's running a microkernel and I see an SSH pair of keys. So it's running an SSH server?
Yeah, the microkernel I built has SSHD in it, just because I got my demo to work on Wednesday, and it just helped with moving things along to have an SSHD in there. But I mean, turning off SSHD is like, the microkernel is built off a kickstart file. This this microkernel is using Fedora 18, and so it's one line in the kickstart file to turn off the SSHD. We should, I mean, that's one command that we should add in is to selectively turn SSHD on and off on some microkernel so that it's easy for you to debug things and keep them secure. So while I've been talking, the microkernel just sits there and checks in with the server every 15 seconds and asks, is there anything for me to do? And so far, the server's been telling it, there's absolutely nothing you can do because we don't have any policies in our server yet. And here's a policy. It's very similar to what I showed in the slides before. And we'll just load that into the server. And let me see if I can catch all the excitement. So here in the background, you see the console of the microkernel. And so I'm going to load this policy. I created what? You
created already.
Yeah. Oh, sorry, yeah, okay. There we go. So, and in a few seconds, we should see we should see the node reboot. Yeah, there we go. So now it's checked in with the server. The server evaluated tags against that node, looked at the policies, and since we have a policy now, it assigned that to the node, and we can look at the node details, or the node log. And that has a few more events now. So it has the boot from before, but now it also has an event that we bound to a policy. And what policy that was, that we told the node to reboot, and then we see the boot that resulted coming from the node in the log. And yeah, I mean, if I look at the node details again, you should now also, for one, because a policy was bound, host names get assigned when you set policy. So a host name was assigned to the thing. We have a root password set in the metadata, because that might be necessary later on to SSH into the node. And yeah, there's a policy on the node too. Okay, and with that, that's all I had. If you have any questions, now's the time. Yeah. Okay.
Microkernel check-in to see if anything to do.
How does the microkernel check in to see if there's anything to do? It's just a little. It's really just a little Ruby script and a systemd wrapper that runs it as a daemon. And so the script just every 15 seconds does a GET request against the server and asks if there's anything to do.
So when you have the boot local, this seems to assume that all the nodes are going to be set to Pixie boot every time they reboot?
Do you have to have all your nodes set to Pixie boot all the time? Yes. Yeah. Razor fundamentally assumes that you're always Pixie booting, no matter whether an OS is installed on the node or there's nothing on it. Yeah, everything needs to be set to Pixie boot. There's a bit of a teaser there for people who don't run DHCP, right? Is that what you're asking? Well, I'm not sure what the best solution for that is, but there's probably ways to do that. But ultimately, Razor fundamentally depends on that. Whenever a machine boots, it becomes aware of that, and it has a way to interfere in the boot process. Okay. Yes.
I had a question, just a comment on that. Sites where we do
Mm-hmm.
time. It's been fairly successful, so I understand that's an issue on your side. I should put it out there. I had a question. What level of integration does it have with Puppet? Is it possible to have Razor connect to your Puppet master and pull down custom facts so that any custom facts are using Puppet are available?
Is it possible to integrate with your Puppet master and pull down custom facts? Right now, it's not. In the current code base, but I think it wouldn't be very hard to put in there, and I think it makes a ton of sense to have you manage the same base of facts across everything where you use factor. Yeah, absolutely. Yeah. Yes?
So in answer to the gentleman's question about executing every time, to have more control over that, we took the ifixing config file that is generated by Razor that's individuated to the Razor server. And then there's the ifixing code base has an ISO process to make an ISO. And so we attach that ISO to VM so that only attaches to the ifixing.
Yeah. Yeah, so I just have to repeat that for the live stream. Yeah, so the comment was that one way to get Pixie booting every time is you can get an iPixie ISO, integrate the command file that the Razor server generates, and then just put that on each of your machines as kind of the default boot thing. And I think that would be the way in a DHCP-less environment to work, right? Because you presumably have networking statically configured. Just boot, yes.
Since if you get a situation where you standardize your hardware a lot and you can't rely on the facts of the hardware to differentiate two machine types, do you recommend just VLANs as the way to handle that, or is there a better way?
Yeah. So the question, I think, is if you have a lot of machines that all look the same from hardware-wise, would you put them on different VLANs so that you can distinguish that way? That's a good question, yeah. And I think, it would probably be something we should catch when a boots.
Right, but if they're all using the same vendor NICs,
Yeah.
they're identical machines, I can rely on the MAC address to tell me which to put, CentOS on these machines and put something else on these machines, or ESX on these machines.
Yeah, yeah. I mean, one way would be that you kind of carve it up and say, I only want this many of these machines and this many of those machines.
Yeah.
Right? That's the main criterion you go by. Yeah. Or I mean, do some networking thing, and yeah, we don't store. I mean, right now we don't store any sort of any information about how the microkernel came in. Yeah, networking, but I mean, it's something we should probably do. Okay.
Maybe I missed this, but after the microkernel boot the big image, does the microkernel close the link?
Sorry?
So right now, the microkernel, after it checks in and it grabs the big Fedora, right? When that happens and it gets installed, does the microkernel goes away or still?
Yeah. So yeah, what happens to what happens to the microkernel when you start installing on the system? So the microkernel is it just runs in memory. There's nothing that gets put on the machine. So once you reboot, the microkernel is gone on that machine, and it's just an install.
So you have to make sure that the machine boots to the disk first, and then to PX.
No, you do not have to make sure that the machine first boots from disk and then PXE. You always PXE boot. The Razor server knows whether that machine should boot into an installer or into the microkernel or should boot locally. And if it knows the thing should boot locally, there's a little ipxe command to do that. Yeah. Yes?
You mentioned in the events section that you had some ideas on certain types of events. Do you envision having just kind of like a user-definable event type where you can sort of trigger at a given point in, for instance, a post script in a Kickstart file, say, all right, I need to notify the Razor server to notify somebody to do something.
Yeah, so the question is, what about user-defined events, basically? And I mean, these are just some rough ideas that I haven't really sat down in detail. To a certain extent, if you generate your events from within your installer, I think that would be very easy to do. If it's at other points in the life cycle, I don't want people to have to muck with the code base, but I mean, it would be if there is a point where an event is needed, it would be a pretty easy feature request or pull request if people submit patches.
Hint taken.
Yes.
If you wanted to update the policy on this, how would you do that? Would you have to just manually reboot the box to contact Razor?
Yes. So how do you update the policy, or how do you force the node to get the latest thing that Razor thinks it should have? Is the box needs to reboot. One of the kind of roadmap features that I would really like to have that I didn't talk about is IPMI support, so that the Razor server could actually go and reboot a machine. There was some in the existing code base just to get kind of the MVP out there. We didn't look at IPMI so far, but I mean, it's a very obvious thing that we need to do. None.
So it looks like you're still calling from the HTTP endpoint, so there's still a REST endpoint for all the calls right now. So I'm seeing in the command line. For
Yeah.
sure, but so is that if I hit that URL, I'm still going to get data inside that URL?
There is the /API URL. Yeah, there's a. I mean, it's HADOS, right? It's the RESTful kind of best practice that there is one global entry point. The command line script is actually, I think that was Daniel's idea. It's actually really, really simple. It just gets the top-level entry point and then navigates from there. The client actually knows very, very little about what a Razor server is. Just knows about the format in which data comes back. And yeah, so you can discover the whole server from this one entry point.
Sorry, one more question. Is the current image store, so with all the templates, is it stored on file or is it stored in the database? Where is that?
So where are templates stored currently? And the answer is both, in the file system and in the database. So because I think for when you're actually writing an installer and mucking around with pre-seed files and post-install scripts and all that, it's much easier if they're in the file system somewhere, because rebooting the systems is bad enough. But then in a production system, you don't want to rely on stuff in the file system probably. And there's a command. You can take the whole installer, stick it into a JSON document, and post it to the server, and set up an installer that way. Okay. Yes.
So with the images themselves, is there an opportunity to sort of separate out the ISO so it doesn't need to get downloaded onto the box? So for example, if I'm installing Kickstart, I can just point
it's it's not in the current code base, but we absolutely need that. Yeah, I mean, the existing Razor was completely ISO oriented, but for like Kickstart installs, everybody who does serious Kickstart installs has their own repo management. And we just need to be able to take a few repo URLs so that you can stick, template them into your Kickstart file. Yes. Back.
We have a microkernel that can pull additional facts from like VMware. So if I wanted to tag a VMF or do it in VMware with some user-defined data, you'll be able to pull that in at the microkernel.
Yeah, I mean, with the code as it is right now, you would need to rebuild the microkernel yourself. Which is not terrible, but it's not fun either. I would like in the future to have a little more dynamic system where the Razor server could actually tell, kind of like how Puppet can download facts, right? Something like that, and probably hooked up to the Puppet master somehow. But right now it means rebuilding the microkernel. What about Windows? Installing Windows with Razor? It's so since installers are really, if you have installation automated to the point where you have the equivalent of Kickstart files and whatnot, it's very easy to stick that on the server. So what it needs is somebody, not me, who knows how to install Windows, to sit down and do it. And if somebody can send me some files and say, this is how I do my Windows installs, I think we can integrate that very, very easily. I mean, it would, shouldn't be very hard. I had some guy from Microsoft talk to me on Wednesday. He has some tools to kind of set up Windows images on a Linux system, but I haven't had a chance to look into them. Yes.
Is there status feedback from the ASIC that you're sending back and forth so that, like in the event that we can pull, you can then take the next action immediately as opposed to just waiting for an arbitrary time?
Right now you just have to poll. There's no, you would like to have some sort of, So when you issue a command, you would probably want a way to get a callback when this command is done, right? We don't have that right now, but I think it also makes a ton of sense.
Okay.
So
The question I have is I'm not really clear exactly how Razor keeps track of the state. It looks like the node identifier, it's keying off the MAC address. So what if you have an existing system where you swap out the network?
That is, So the kind of previous Razor did everything by NICs. And I think that is a little problematic. I talked to somebody on Wednesday who was using Dell service tags, which you actually can get from the iPXE. And we need to, I don't think it's a huge step to make it possible to change what is used as the identifier for a system. We just should do it really, really quickly before assumptions get baked into the code base about MAC addresses. And the only thing you really need to have something, a valid identifier, is iPXE needs to be able to get to it, and Factor needs to be able to get to it.
In our environment, that's exactly what we do. We actually, on our hardware, we actually insert into the BIOS tag so that we can track. So if we can key off that,
Okay, I'm sorry, I'm super out of time. Thanks, everybody.